The world we live in is an amazing place. Every corner keeps millions of riddles and secrets. And probably the largest of them is located above the head. The cosmos is mesmerizing. Looking at the night sky, it seems that to reach the stars, you just need to stretch your hand up. Hardly anything in the world can be so close and so far at the same time. Humanity's interest in space has never faded. Back in ancient Greece, people looking at the stars tried to understand how our world works. Since the Renaissance, astronomers initiated research with the first telescopes. In 1903, after the flight of the Wright brothers, the development of aircraft construction began. And only 58 years later, Yuri Gagarin flew into space. And it was just a beginning. The conquest of space cannot become a reality without the development of science. Among many scientific industries, I cannot fail to mention electrochemistry, which is a unique combination of physics and chemistry. The most fantastic ideas can be realized using electrochemistry. For example, the development of chemical current sources. When the first Soviet satellite was launched on October 4, 1957, more than 38% of its total weight was chemical current sources. Small satellites weighing hundreds of grams required watts of energy. Not to mention manned spaceships, which required significantly more power. How can we get it? In order to understand this, we need to go back in time. About 200 years ago. So, let's start. So, now is 1835. William Robert Grove just graduated from Oxford and became a lawyer. But in the evening, taking off his judge's robe, he engaged in his favorite science, electrochemistry. And these classes are going very successful. In 1839, he tries to decompose a sulfuric acid solution by the electric current into hydrogen and oxygen, and accidentally notices that the galvanometer needle is deflected when it is connected to two platinum strips half submerged in a vessel with dilute sulfuric acid. One strip was blown with hydrogen and the other with oxygen. The fact that the process can go in the opposite direction and produces the electric current for Groves, it was a side phenomena, and the message about it was placed in the postscriptum of the manuscript. Grove's experiments also did not make a big impression on scientists at that time. Curious, but has no practical interests. Also, think about it. You can burn hydrogen and get water. And what is most surprising, when burning ordinary fuel is not heat, but immediately electric current. Initially, this novelty was called the Groves element. But then, when it became clear that it was possible to burn not only hydrogen, but also coal and other fuels, another name was given to it. It was called the fuel cell. When the question arose in the United States about the choice of power plants for the Gemini spacecraft, the choice fell on fuel cells. They are compact and can have any geometric configuration in accordance with the requirements of the spacecraft. They are insensitive to shock, vibration, radiation, noiseless, do not give radio interference and harmful radiation. And so it happened that the first practical application of fuel cells was found not on Earth, but in space. Well, the experience gained during the Gemini program was used in the preparation and implementation of the Apollo program. The Apollo fuel cell battery consisted of 3 independent sections, with 2 sections each having enough power for normal operation, each of which weighed approximately 120 kilograms. In each section, 31 elements were connected in series. The section operated with a power up to 1420 watts. With a short-term load, up to 2.3 kilowatts of power could be obtained. In space, these power plants worked quite well. They ensured the fulfillment of the main goal of the Apollo program. The Apollo 11 and Apollo 12 spacecraft delivered astronauts to the Moon and returned them to Earth. However, during the flight of the Apollo 13 spacecraft, an accident occurred in the oxygen tanks of the power supply system.
Houston, we've had a problem.
But the astronauts safely returned to Earth with the help of storage batteries. Today, the role of electrochemistry in space is even more diverse. The abundance of solar radiation and our ability to convert a significant part of it into electricity allows not only to efficiently store battery energy in space, but also to use electricity for life support and scientific experiments. Our desire to explore and overcome problems prompted us not only pursue a technical career, but also ask an important question about our place in the universe. And I believe that the contribution of every researcher will be extremely useful on the path to the stars.